welcome to Microchip Web Seminar. My name is Robin Rochvanit, and I am an applications engineer here at Microchip Technology. With the introduction of the PIC18F4550 family, which has a full-speed USB peripheral, many more USB applications have become possible. One such application is the enumeration of RS-232 over USB, and that's exactly the topic that we will be talking about today. This presentation is only about 20 minutes long, and not everything can be explained here. Therefore, the goal of this presentation is to describe what the RS-232 emulation over USB is, what it is useful for, what Microchip is providing, and where to find more information. For those of you who are new to USB, I would like to go over a few terminology first. The first word we will be covering is the word USB itself. USB stands for Universal Serial Bus, and in the past few years, USB has literally become the standard peripheral interface for every personal computer. The next word is CDC, stands for Communication Device Class. This is a device-level protocol specification defined by the USB Association Body. It defines the rules of how a USB host and a USB peripheral should communicate as a communication device. And specifically, the CDC specification defines a wrapper protocol layer around other communication protocols, such as the RS-232, allowing them to be transported over the USB interface. Another plus side of using the standardized specification is that it allows a USB host and a USB peripheral to be developed independently. As I will explain later on in this presentation, no work or modification is required on the PC side to implement the RS-232 emulation over USB. And this is so because Windows 2000 and XP already come with a driver which provides the RS-232 emulation capability as defined by the CDC class specification. And that is a good news for us because therefore the only things left to do is for the embedded device to have the hardware and firmware support that conform to the CDC specification. Nothing that you have to do on the PC side. Great news. Next term, VID. VID stands for Vendor ID. The Vendor ID number is a 16-bit number assigned by the USB organization body. This number has to be purchased by every manufacturer in order to market and sell a product. The next one is very similar to Vendor ID, but it's called PID, which stands for Product ID. It is also a 16-bit number, and this means each manufacturer has 65,536 product ID that they can use. And with these two numbers, it is a requirement that every product is required to have a unique combination of vendor ID and product ID. So that is just so what I've explained so far is just a basic coverage about the term that we'll be using in this presentation. And if you want more details regarding these terms or more information about USB itself, please visit the following website, www.usb.org. That is the official USB organization body. And the official term for them is USB Implementer Forum, and we just call them, in short, USB IF. Now let's jump into the main topic. RS-232 emulation over USB. The emulation of RS-232 over USB provides an easy migration path for an embedded application. The serial communication has traditionally been the most common method of transferring data between a PC and an embedded device. This slide is showing you the traditional method of transferring data over the RS-232 interface. The top half of the screen represents a personal computer, and the bottom half represents an embedded application. The HyperTerminal is a Windows program that is used here as an example of an application. Now, the deal is many computers no longer have a serial port. This fact causes a headache for many embedded system designers, and a new solution is pretty much needed. And an answer to that is, of course, voila, use the USB. So, this slide shows the migration path from using the RS-232 interface to USB. The UART physical layer is replaced with the USB hardware layer, as shown in the green color. Since the CDC is a standard USB class, Microsoft has implemented a driver which supports the RS-232 interface emulation. On the PC side, the CDC driver, which is being shown right here. Hold on one second. Right here. Oops. Right there, as you can see. That's the driver I'm referring to. Okay. It provides a linking layer between the USB hardware and the UART driver. This allows the end application, in this case the HyperTerminal, to remain unchanged because from its perspective, it still sees the RS-232 interface. As for the embedded application side, the PIC18F4550, which is right down here, has a full-speed USB peripheral. In addition, Microchip also provides the CDC RS-232 emulation reference project, which provides necessary application programming interface in this layer right here. So that's basically the overview of what the RS-232 emulation over USB is about. Now, I would like to introduce you to the PIC18F USB demo board. This board can be purchased from buy.microchip.com or any Microchip distributors. It provides a hardware platform for demonstrating the USB capability of the PIC18F4550 family of devices. Assuming that the board has the CDC RS-232 emulation reference project loaded, I will next show you how the demo board would be recognized by the Windows operating system when we plug this into a personal computer. So let's assume right now that we basically are using my computer, which has two physical RS-232 ports, and at this particular point, I do not have the demo board connected to my system. And therefore, when I go to my device manager and go and browse to see how many COM ports do I have, I see two, COM1 and COM2. And those two items represent the two physical RS-232 ports that I have on my system. The next thing that I would do is then connect my demo board to my PC system. At this point, Windows should detect a new USB device and will pop up the following screen asking the user for further instructions. I selected Install from a list or specific location, Advanced, then I click Next. On the following screen, Windows will then ask for the location of the INF file. A standard INF file for the communication device driver is not provided by Microsoft, but one is provided by Microchip. Example INF file is part of the CDC RS-232 emulation reference project. Once installed, it can be found in the directory listed on this slide, which is C, MCHP-FS USB, firmware, CDC, INF, Win2K, WinXP. Please note that the USB product ID and vendor ID that I have explained earlier in this presentation are also contained in the INF file. This means when you use the reference project, you should change the IDs in both the firmware and the INF. Windows uses this database to make sure that it associates the correct driver with the correct device. So after I click next and open up my device manager again, now I see 3 COM ports. So let's recap. I have 2 physical RS-232 ports, and I have my PIC18F demo board connected to my personal computer, and I utilizes the RS-232 emulation capability of the CDC class, and now I have 3 COM ports. So let's try in the next step to see how an application would use this feature. Next thing I would do is to launch the HyperTerminal. And the first thing it will ask me to do is to type in a name for the connection. I type in PIC18F and I hit OK. And then it asks me to select the COM port I want to open the connection to. In this case, I want to open the connection that is associated with the demo board. In this case, it is COM3. I selected it and I hit OK. Then the HyperTerminal asks me to set up the COM3 properties. Since this is an emulation USB interface, a lot of these settings have become abstract, and you can literally select anything you want here and hit OK to continue. And the default code that you would use from the reference project, once you have it running and everything is connected, the default program have it in such a way that when you hit S2, the switch button 2 on the demo board, it will send the following message to the host USB. In this case, it reads Microchip Technology Incorporated 2004 and PIC18F4550, blah, blah, blah. So this shows that the end application, the HyperTerminal program, is basically just opening a COM port, but it's really talking to a device that is connected through an USB interface. And this is a really pretty neat feature in a sense that if you want to migrate your application from a RS-232 based device to USB, all your work is basically on the device's side, and you hardly have to do anything on the PC side. I would like to point out an important note. Before physically disconnecting a USB device, you must hang up the connection first. Otherwise, the program must be closed and open again the next time a USB device is connected. So just remember to do that when you use the HyperTerminal. Now let's look at the APIs provided by the CDC reference project for the firmware. There are 1, 2, 3, 4, 5, 6, 7 basic functions provided as part of the reference project. And it allows you to transfer data from the device to the PC or to read data from the PC itself. So there are 7 functions right there. You would have thought that you only needed 2, but the library itself actually provided a few more just to provide an easy way to send over strings of text and so on. And detailed information of each function can be found in application note AN956. I'll show you the link later on in this presentation, so if I don't talk about them in too much detail here, don't be afraid. You can find more information later on. I also would like to point out that the reference project itself is also a tutorial of how to use the API library. So what this slide is showing you is basically the basic program flow of the reference project. After the device has reset, and you can see that event on the top left-hand side corner of the screen, and following along with the arrows, it will then enter the main function. And then the next thing that the program does is it initializes the system. Then it goes into a main loop. 2 main things are being called in there: USB task, process I/O. The one you want to pay attention to is the process I/O, and that function is declared in the file user.c, and you can find that in the MPLAB project once you have opened up the reference project. And what you can do then is to go to do a search for each of the following functions: exercise 01, exercise 02, 03, 04, and 05. The instruction of what to do in each of those exercises is described in the function header. So go ahead and download the reference project, install the program, and take a look at user.c and learn how to use the library itself. Next thing we're going to talk about is to compare the performance of this solution versus others. Talking about speed, from the practical standpoint, it has been observed that the bandwidth that this solution could provide is roughly 80 kilobytes per second. This is faster than using the RS-232 connection. And keep in mind that this solution is not possible with a low-speed USB device because it does not have a bulk endpoint. If you do not know what a bulk endpoint is, do not have to worry. Just know that a low-speed USB peripheral cannot use this solution. The program memory required to use this solution is approximately 3 kilobytes, and this does not include the user's program, so it just has the core USB driver and the CDC firmware wrapper around it. Now, I would like to tell you where you can go and find more information for yourself. If you go to the World Wide Web and type in worldwideweb.microchip.com/USB, it will take you to the page shown on the bottom right-hand side of the screen. This is the home page of the USB Design Center. In there, you can find a wealth of information. But for this particular reference to the CDC firmware, you just have to scroll down toward the middle of that page, and there's a link to the communication device class firmware. Click on there, and it will take you to the following page. Now, this is the AppNode homepage for the AN956. Toward the bottom right-hand side, there are two links available. One is to the PDF file of the application node itself, which has a detailed descriptions of what the RS-232 emulation class is. And the second link points to the source code and the INF file. Once you have downloaded the installation file and installed it, you will see the following directories. You might not see all of this because you could have downloaded something else and put them on top of each other. But just for the CDC class alone, just pay attention to what is being shown in that little black square box right there. This is the CDC reference project. Under CDC, you would find the mchp usb.mcw. This is the workspace file. So when you go into MPLAB IDE and you want to start up the reference project and try to see what you can do with the code and whatnot, the file that you would want to open is the workspace file. And when you want to upload your code to a target board, the output hex file can be found under the _output directory. And when you plug your device in to the Windows system for the first time, you can tell Windows where the INF file is located, and it's being shown right there under CDC/INF. So to summarize, emulating RS-232 over USB is the easiest transition from the traditional method of communication because it requires no changes for the PC application, and you can continue using the COM1, COM2, etc. And remember that CDC RS-232 emulation reference project is freely downloadable from www.microchip.com. And And that is pretty much it for today. Thank you very much for attending, and check back regularly for other information on other web seminars. Thank you very much.